Now in this lecture we find out the area of a circle. In the drawing we have trapezoid ABCD. This circle is inscribed by trapezoid ABCD, or trapezoid ABCD blocks the circle. In addition, we know that side AB of trapezoid ABCD equals to 3 units in its length, and the area of trapezoid ABCD is equal to 3 square units in its size. In addition, we know that this is angle ADC, that is a right angle. This is angle BAD, that is also a right angle. Again, our task is to find out the area of this circle that is inscribed by trapezoid ABCD. So, first of all, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is quadrilateral ABCD. In quadrilateral ABCD, side DC is parallel to the opposite side AB, and therefore quadrilateral ABCD is defined as a trapezoid because it has one pair of parallel sides. If we define the length of side DC as A and the length of side AB as B, then the area of trapezoid ABCD will be equal to the sum of its two parallel bases. The two parallel bases DC and AB, or the two parallel sides DC and AB, are defined as the bases of trapezoid ABCD. So the area of trapezoid ABCD equals to the sum of its two parallel bases, that is to say A plus B times the height edge over 2. The height edge must create 90 degrees with the two parallel bases. So repeat again, a trapezoid is a quadrilateral with one pair of parallel sides, and the area of trapezoid is equal to the sum of its two parallel bases. In this case, it is A plus B times the height edge over 2. So first of all, we define the relevant points to this question with letters. We define the center of this circle. This point is point O. We define the point of tendency of tangent DC with this circle. This point is point E. We define the point of tendency of tangent DA with this circle. This point is point F. We define the point of tendency of tangent AB with this circle. This point is point G. And we define the radius of this circle as x. This is point O. This is point F. This is point G. And this is point E. So according to our definition, the radius of this circle is x. We join points O and G together by straight line. OG, point O is the center of the circle, point G is the point of the circle itself, therefore OG is the radius of this circle, that is equals to x according to our definition. The radius OG that is equals to x, the radius OG is drawn to point G, that is the point of tendency of tangent AB with this circle. And whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius GO. If AB is perpendicular to GO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and F together by a straight line. OF is of course the radius of this circle that is equals to x. The radius OF that is equals to x is drawn to point F, that is the point of tendency of tangent AD with this circle. And now you have this is known to the verse of tendency, then tangent AD will be perpendicular to the radius F4. If AD is perpendicular to F4, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the symbol or 1. So in quadrilateral FOGA we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth angle must be equal to 90 degrees in its size. So in quadrilateral FOGA we have 4 right angles, and therefore quadrilateral FOAG must be this rectangle in front of the square. So we have to quadrilateral FOGA is a rectangle, but we know that the opposite sides of a rectangle are equal to each other. So in rectangle FOGA, side OG must be equal to the opposite side FA. But OG is x, therefore the opposite side FA must be also equal to x units in its length. We join points O and D together by a straight line. O is of course the radius of this angle is equals to x. According to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So in quadrilateral EDFO we have 1, 2, 3 right angles, and therefore this fourth angle must be equal to 90 degrees, and therefore can relate to quadrilateral FOED is a rectangle because it has 4 right angles. But you also know that the opposite sides of a rectangle are equal to each other. So rectangle DEOF, side EO must be equal to the opposite side DF. But EO is x, therefore the opposite side DF must be also equal to x units in its length. So in total DA equals to x plus x, that is 2x. So AD equals to 2x units in its length. So written down, so as we found out that dA equals to 2x units in its length. In the next step, we define the length of side DC as A, and we will do a construction, that is to say, from point C we will go perpendicular on AB. Again, from point C we will go perpendicular on AB. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AB. This point is point M. Before we continue, we know that in trapezoid ABCD, side AD plus the opposite side BC is equal to side AB plus the opposite side DC. So as you know, this trapezoid ABCD, DA plus CB DA plus CB equals to DC plus AB. We already proved in the first lecture that DA plus AB equals to this DA plus CB. Again, DC plus AB equals to DA plus CB according to rule 2. Repeat again. In trapezoid ABCD, DA plus CB equals to DC plus AB. DA is 2x plus CB. CB is the missing side, so we leave this it is. And it is equal to DC. DC equals to A plus AB. AB equals to 3 units in itself according to what is given us the question. So in total, we found out that 2x plus CB equals to A plus 3. Again, 2x plus CB equals to A plus 3. Here we subtract 2x from this equation, and we get that the missing side CB equals to A plus 3 minus 2x. So actually, this is the missing side CB is equals to A plus 3 minus 2x. Now this equals to A plus 3 minus 2x. So we did a construction from point C with no perpendicular on AB. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. By doing this construction, we can do the quadrilateral DCMA. In quadrilateral DCMA, we have 1, 2, 3 angles. Therefore, this fourth missing angle must be equal to 90 degrees in its size. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So in quadrilateral, in the big quadrilateral DCMA, we have 4 angles. Therefore, we can write quadrilateral DCMA as a rectangle because it has 4 angles. But we also know that the opposite sides of the rectangle are equal to each other. So in the big rectangle DCMA, side DC must be equal to the opposite side AM. But DC is A, therefore the opposite side AM must be also equal to A units in its length. Likewise, according to the sum rule, in the sum rectangle DCMA, side DA must be equal to the opposite side CM. But DA equals to 2x, therefore the opposite side CM must be also equal to 2x units in its length. What is the length of the missing line segment? Line segment MB. From the drawing, it is very easy to see that MB equals to AB minus AM. Again, MB equals to AB minus AM. So the norm, we found out that the missing side MB equals to AB minus AM. So MB equals to AB is 3 minus AM. AM is A according to our definition. So in total, we actually found out that the missing side MB equals to 3 minus A units in its length. In the next step, I'll copy the right angle CMB in a new page and we'll implement on this right angle CMB the Padolas theorem. According to the Padolas theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for Pythagoras theorem. So here, this is the right angle CMB, this is the coordinate of the original drawing. This is right angle CMB, CB squared, that is the square of the hypotenuse, equals to CM squared plus MB squared. So already know, CB squared, that is the square of the hypotenuse, equals to CM squared plus MB squared. CB is 8 plus 3 minus 2x, and therefore CB squared is 8 plus 3 minus 2x squared. And it is equal to CM squared. CM is 2x, therefore CM squared is 4x squared. Plus MB squared. MB is 3 minus 8, therefore MB squared is 3 minus 8 squared. So total we found out that A plus B minus 2x squared equals to 4x squared plus 3 minus 8 squared. So we will open the brackets on both sides of this equation, and we get that A plus B minus 2x squared. We'll open the brackets according to the algebraic identity that says that A minus B squared equals to A squared plus B squared minus 2 times A times B. So A plus B minus 2x squared equals to A plus B squared minus CB equals to A plus 3 minus 2x, therefore CB squared equals to A plus 3 minus 2x squared, so it is A plus 3 minus 2x squared. So A plus 3 minus 2x squared equals to A plus 3 squared plus 2x squared, that is 4x squared, minus 2 times A plus 3 times 2x. So A plus B minus 2x squared in total equals to A plus 3 squared plus 4x squared minus 2 times A plus 3 times 2x. And it is equals to 4x squared plus 3 minus A squared. So A plus 3 squared is equal to A squared plus 3 squared, that is 9, plus 2 times A times 3, that is plus 6A, plus 4x squared, minus 2 times 2x is minus 4x times A plus 3, and it is equal to 4x squared plus 3 minus A squared. 3 minus A squared equals to 3 squared, that is 9, plus A squared, minus 2 times 3 times 8, that is minus 6A. Here we have 4x squared on both sides of the equation, so 4x squared will get cancelled. We have also 9 on both sides of the equation, so 9 also will get cancelled. And we have also A squared on both sides of the equation, so A squared also will get cancelled. So on this side of the equation we left only with 6A minus 4x times A plus 3 equals to minus 6A. Here we add 6A to this equation, and also 4x times A plus 3, and we get that 6A plus 6A is 12A equals to 4x times A plus 3. So 12A equals to 4x times A plus 3. Here we divide this equation by 4, and we get that 12a over 4 is 3a, so 3a equals to 4x over 4 is x times a plus 3. So in total we found out that 3a equals to x times a plus 3. Here we divide this equation by a plus 3, and finally we get that x equals to 3a over a plus 3. Repeat again, if we found out that x is the radius of the circle, is equals to 3a over a plus 3. What is the area of trapezoid ABCD? According to the formula that I presented to you at the beginning of the lecture, the area of trapezoid ABCD will be equal to the sum of its two parallel bases, that is to say DC plus AB times the height over 2. The height is cm because it's creates 90 degrees with two parallel bases. This angle equals to 90 degrees and this angle also equals to 90 degrees. So the height is cm over 2. So in total we found out that the area of the trapezoid ABCD equals to the sum of the two parallel bases, that is to say AC plus AB times the height cm over 2. DC is A plus AB. AB is 3 times cm. cm is 2x over 2. So in total we found out that the area of this trapezoid ABCD is equal to A plus 3 times 2x over 2. But it is given as the question that the area of trapezoid ABCD equals to 3 square units in its size. So we can substitute the area of trapezoid ABCD by 3, and we get that 3 equals to A plus 3. We have 2 in the denominator, so 2 gets cancelled, and we left only with x. So it is A plus 3 times x. So in total we found out that 3 equals to a plus 3 times x. But we have already found out that x equals to 3a over a plus 3. So we can substitute x in this equation by 3a over a plus 3. We do it now and we get that 3 equals to 3 plus a times x. And x equals to 3a over 3 plus a. So we have 3 plus a in the denominator, 3 plus a in the denominator, so 3 plus a will get cancelled. And we're left only with 3 equals to 3a. Here we divide this equation by 3 and get that a equals to 3 over 3, that is 1. So if you found out that a equals to 1 unit in its length. So we can substitute in this equation x equals to 3a over a plus 3 by 1. X equals to x equals to 3a over a plus 3. And a equals to 1, so x equals to 3a is 3 times 1, that is 3, over a plus 3. A is 1, so a plus 3 is 1 plus 3, that is 4. So in total we found out that x, that is the radius of the circle, is equal to 3 quarters units in its length. Our task is to find out the area of this circle that is inscribed by this trapezoid ABCD. You know that the area of any circle is equal to pi times the radius of the circle squared. Repeat again, the area of any circle equals to pi times the radius of the circle squared. And therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius square is x squared. So in total, the area of our circle equals to pi x squared. But x is 3 quarters, therefore x squared is 3 quarters squared. 3 quarters squared is 9/16. So in total, we found out that the area of this circle, that is the area that we were looking for in this question, is equal to either 9 pi over 16 square units in its size, or in terms of numbers, it is equal to 1.767 square units in its size. And that is the answer to the question. I repeat again, if we found out that the area of this circle is equal to either 9 pi over 16 square units in its size, or in terms of numbers, the area of this circle equals to 1.767 square units in its size. So the next step, I'll summarize the lecture. Our task in this lecture is to find out the area of this circle. This circle is inscribed by trapezoid ABCD. What is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. And the area of a trapezoid equals to the sum of its two parallel bases. In this case, it is DC plus AB times the height CM over 2. The height CM must be equal, must create 90 degrees with the two parallel bases. Again, the area of a trapezoid equals to the sum of its two parallel bases times the height over 2. And the height must create 90 degrees with the two parallel bases. So we define the relevant points to this question with letters. We define the point of tendency of tangent DC with this circle, this point is point A. We define the point of tendency of tangent DA with this circle, this point is point F. We define the point of tendency of tangent AB with this circle, this point is point G. So here, actually implemented rule 1 in our drawing. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. First of all, we defined the radius of this circle. This is the same drawing, like here. So we define the radius of this circle, that is the radius of its area that we are looking for in this question. We define the radius of this circle as x. The center of this circle is here at point O. We join points O and G together by straight line. OG is the radius of the circle that is equals to x. And because of the fact that the radius OG is drawn to point G, that is the point of tendency of tangent AB with this circle, therefore according to rule 1, whenever we have the radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius GO. If AB is perpendicular to GO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and F together by a straight line. OF is the radius of the circle that is equal to x, and according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points O and E together by a straight line. O is the radius of the circle that is equal to x, and according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So in quadrilateral FOGA, we have 1, 2, 3 angles, and therefore this fourth angle must be equal to 90 degrees in its size, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, quadrilateral FOAG is at least a rectangle in front of the square, so we know to quadrilateral FOAG is a rectangle, but we know that the opposite sides of the rectangle are equal to each other. So the rectangle FOGA, side OG must be equal to the opposite side FA. But OG is x, therefore the opposite side FA must be also equal to x units in its length. So in the upper quadrilateral DEOF, we have 1, 2, 3 rectangles, and therefore this fourth missing again also will come to 90 degrees in size. Therefore, quadrilateral EDFO is a rectangle, but we also know that the opposite sides of a rectangle are equal to each other. So an rectangle EOFD, side EO must be equal to the opposite side DF. But EO equals to x, therefore the opposite side DF must be also equal to x units in its length. So in total DA equals to x plus x, that is 2x. So DA equals to 2x. DA, it is one side of trapezoid ABCD, therefore it is absolutely straight lines. Therefore DA in total equals to x plus x, that is 2x. And we know that in trapezoid ABCD, side DC plus the opposite side AB equals to the side DA plus the opposite side CB. We actually proved it in the previous lecture. It is true according to rule 2 that says that the lengths of two tangents from a common external point to a circle are equal. For that reason, DC plus AB is equals to DA plus CB. And again, we already proved in the previous lectures that in trapezoid, any trapezoid, DA plus CB equals to DC plus AB. DA equals to 2x plus CB. CB is the missing side, so limit is it is. So it is this side of the equation we have 2x plus CB, and it is equals to DC. DC, according to our definition, DC equals to A plus AB. AB is 3. So in total, we found out that 2x plus CB equals to A plus 3. Here we subtracted 2x from this equation, and we found out that the missing side CB equals to A plus 3 minus 2x. And again, this is the missing side CB. This is the missing side CB. Is equals to A plus 3 minus 2x. In the next step, we did the construction. That is to say, from point C, we draw perpendicular on AB. Again, from point C, we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AB. This point is point M. By doing this construction, we can do the quadrilateral DCMA. In quadrilateral DCMA, we have 1, 2, 3 right angles. Those two angles are right angles according to what is given as the question, and this is the right angle according to our construction. So in quadrilateral CDAM, we have 3 right angles, and therefore this fourth missing angle must be equal to 90 degrees in its size. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Quadrilateral DCMA has 4 right angles, therefore we can write quadrilateral DCMA as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in the big rectangle DCMA, side DC must be equal to the opposite side AM. But DC is 8, therefore the opposite side AM must be also equal to A units in its length. Likewise, according to the third rule, in the same rectangle DCMA, side DA must be equal to the opposite side CM. But DA is 2x, therefore the opposite side CM must be also equal to 2x units in its length. What is the length of this missing line segment MB? MB equals to AB minus AM. MB equals to AB minus AM. So MB in total equals to AB, that is 3. Minus AM, that is A. So in total, MB equals to 3 minus units in its length. We have already found out that the hypotenuse CB of the right angle CMB equals to A minus A plus 3 minus 2x. Side CM equals to 2x, and side MB equals to 3 minus A. So copy the right angle CMB in a new page, and we implemented the Pythagoras theorem on this right angle CMB. According to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, this is the right angle CMB that according to the original domain. In this right angle CMB, according to the Pythagoras theorem, CB squared, that is the square of the hypotenuse, equals to CM squared plus MB squared. CB is a plus 3 minus 2x, therefore CB squared is a plus 3 minus 2x squared, and it is equals to CM squared. CM is 2x, therefore CM squared is 4x squared, plus MB squared. MB is 3 minus a, therefore MB squared is 3 minus a squared. We open the brackets on both sides of this equation. Open the brackets of this expression according to the rule that, to the algebraic identity, that a minus b squared equals to a squared plus b squared minus 2 times a times b. So according to the algebraic identity, a plus 3 minus 2x squared equals to a plus 3 squared plus b squared, that is 2x squared, that is 4x squared, minus 2 times a plus 3 times 2x. So this is minus 2 times a plus 3 times 2x. And it is equals to 4x squared plus 3 minus a squared. So we open the brackets here. A plus 3 squared equals to a squared plus 3 squared, that is 9, plus 2 times a times 3, that is 6a, plus 4x squared. And we have here minus 2 minus 2x is minus 4x times a plus 3. And it is equals to 4x squared plus 3 minus a squared. 3 minus a squared equals to 3 squared, that is 9, plus a squared minus 2 times 3 times a, that is minus 6a. Here we have a squared on both sides of the equation, so a squared will get cancelled. We have 9 on both sides of the equation, so 9 also will get cancelled. And we have 4x squared on both sides of the equation, so 4x squared will get cancelled. So in this side of the equation, we have to only with minus 4x times a plus 3, and we have also minus 6a. We have only with 6a minus 4x times a plus 3. In the other side of the equation, we left only with minus 6a. So in total, we should know that 6a minus 4x times a plus 3 equals to minus 6a. So here we added 6a to this equation, and we found out that 6a plus 6a is 12a, and we had simultaneously also added 4x times a plus 3 units to this equation. In total, we found out that 12a equals to 4x times a plus 3. Here we divided this equation by 4, and we found out that 12a over 4 is 3a, and 4x over 4 is x. So in total, this expression equals to x times a plus 3 equals to 3a. So 3a equals to x times a plus 3. Here we divided this equation by a plus 3, and finally found out that x equals to 3a over a plus 3. And again, I should find out that x equals to 3a over a plus 3. I already presented to you in the beginning of the lecture that the area of the trapezoid is equals to the sum of its two parallel bases times the height over 2. So the area of this trapezoid ABCD equals to the sum of its two parallel bases, that is to say DC plus AB. The sum of its two parallel bases, that is DC plus AB, times the height CM over 2. Times the height CM over 2. DC is A, AB is 3, and CM is 2x. Repeat again. DC is A, AB is 3, and CM is 2x. Divided by 2. Repeat again. The trapezoid equals to the sum of its two parallel bases times the height over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we have to only with a plus 3 times x. So, but it is given us the question that the area of trapezoid ABCD equals to 3 square units. Therefore, we can substitute the area of trapezoid ABCD by 3. In total, we shall find out that 3 equals to a plus 3 times x. Here, we substitute x by 3a over a plus 3. Again, we substitute x here by 3a over a plus 3. And we found out that 3 equals to a plus 3 times x, that is 3a over a plus 3. We have 3 plus a in the numerator and 3 plus a in the denominator, so 3 plus a gets cancelled, and we left only with 3 equals to 3a. Here we divided this equation by 3, and finally found out that a equals to 1. A equals to 1, therefore we can substitute 1 in this equation, we can substitute a in this equation by 1. Repeat again. We already found out that x equals to 3a over a plus 3, and just right now found out that a equals to 1. So we substitute a by 1 in this equation. We can find out that x equals to 3 times a is 1, so 3 times 1 is 3, over a plus 3. A is 1, so a plus 3 is 1 plus 3, that is 4. So in total we found out that x, that is the radius of the circle, is equals to 3/4. Our task is to find out the area of this circle that is described by trapezoid ABCD. Actually, we know that the area of any circle equals to pi times the radius of this circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle squared is x squared. So in total, the area of our circle must be equal to pi x squared. X is 3/4. So we substitute x by 3/4. If x is 3/4, x squared must be equal to 3/4 squared. 3/4 squared is 9 over 16. So in total, if you found out that the area that we are looking for in this equation, that is the area of this circle, equals to either 9 pi over 16 square units in its size, or in terms of numbers, the area of this circle equals to 1.767 square units in its size. Okay, thank you very much.